approach the measurement of tandem cells and tandem modules. And please, you don't have to 2 terminals, 3 terminals, 4 terminals. Please, you have some idea.
We start with 2 terminals, okay?
Okay.
Yeah, so, but I mean, you asked about the challenges. What I think obvious companies see as challenging is like to have stable cells at all. So, I mean, there's 2 stability issues I think in perovskites. It's one, the cell could actually degrade and really get worse, or just a metastable defect or defect in which could be reversed. So you have to take into account these 2, like with very fast or very slow measurements, and with preconditioning. And then there's the spectrum issue, the spectrum mismatch. So, I mean, if you want to measure perovskite or tandems, you would need actually really the perfect AIM 1.5 G spectrum. But there is no light source which is capable of doing this. So you always have to do, or you have to know your EQE of the subcells, and then if you fit your LEDs, so in our case we can fit our LEDs and also to the EQE of the cells, and we have this combined effect. But yeah, I mean, we as a company are in perfect position for tandems with our 27 LEDs now in the cell tester. We can tune the red and the blue parts to get the spectrometric polarization. But yeah, in the end, it's also about norms, I guess. Because, I mean, as I said, there is no perfect AIM 1.5 T spectrum, so you have to agree kind of on how you like calibrate your spectrum or your not so perfect spectrum to the actual measurement then.
But I mean, for you, especially for us, it's very important to have a stable measurement condition. Because if the efficiency or the current or whatever is changing continuously, I think this measurement is disqualified. And we learn from perovskite, when you have these changes, how you can, what is your idea? How this can be solved?
Yeah, so if I could present a solution that I think would be nice. But yeah, so we saw the upcoming tandem and or perovskite technology also as a big challenge, but also as a big opportunity. So this is why we also started some years ago developing our LED light source, because obviously this xenon, this might be not possible in the future. So we also started in the same time to figure out how to measure these kind of cells, and we had a lot of trouble, like you said, getting samples to actually do some testing. So even the samples we got were quite quickly dead or unstable in general. So so even in laboratory environment, it was very difficult to get measurement out of these cells or cell samples. And I think there are some methods now which are quite commonly known when you light source these things, or there are different methods to get kind of a measurement out of these, but we are very far away from the industrial solution in my eyes. This is the problem. So, and honestly, I cannot present any ready-to-go solution. So this is something we need to figure out, and where we are working on together with several bodies which are in this development. So we try to collaborate with them and get examples from them, and then figure out how to measure these in an industrial environment in a high frequent system. So yeah.
Okay. And you, Harris, I mean, you're perhaps representative of perhaps offline solutions. Then you have these stacked layers, and let us assume a two-terminal tandem cells. How you can make any extraction? I don't know.
Okay, so for comparison, you can back out a lot of parameters from an IV curve of a silicon cell, because silicon is one of the most characterized materials in the world, and we know so much about its physical properties. And that's the big hole that we see right now. We don't know all the physical properties of perovskite materials. So to the extent that we want to do more characterization, more measurements, we want to focus on what are those core material properties, something as basic as mobility, ionic diffusion, how the crystallinity, all those kinds of things at a very more basic material science level. Once we have more fundamental material properties, then we can start to say, forward predict how that affects IV curves. But starting at IV curves, which is what we want to do because we can see their high efficiency above 30% tandems, and trying to back your way out without a good physical model, we're going to be lost in the dark. So we have to actually start at this end And that's the kind of information and those types of projects we're trying to support.
And you have to measure these big, perhaps confusing modules. What is your idea?
Yeah, we already delivered quite some equipment to the pioneers that are scaling up perovskites to mini modules and even to full-size tandem modules. And
4 terminal or 2 terminal, or which type?
Also 2 terminals. What we see some consensus coming, some standardization coming in the test procedure. I can tell that in general it's very good to have about 5 to 10 minutes of stabilization in NPP, while NPP tracking, steady state light, with it's called deterb and observe NPP tracking, that you change it a bit and then see if Tmax goes up. Don't do that too fast because a perovskite device might oscillate. You get all kind of nice effects. So 5 to 10 minutes of stabilization in NPP and steady state light, and then a slow IV sweep. Take half a minute or 30 seconds, 60 seconds, look forward, backward to take out the IC, VOC, shunt and series resistance. That's definitely a recommendation that I see from the consensus in the standards. Also, when making it tandem devices, indeed the tandem ranges have need spectrum tuning. So indeed, like we do on the LED machines, tune the 2 wavelength ranges. And the third one is it makes sense to test it at 25 Celsius because typically you have different temperature coefficients as well. So that is what we have learned with scaling up perovskites to mini modules and in the working groups and standards. Yeah.
But that, if I'm allowed to add a question, I mean, normally you're used to flash modules. So that you are saying this is, if you have 2 terminal, whatever terminal, then this you can forget. Flash testing will not work anymore.
Well, what you see for thin films as well, that you, for example, what you can do in a production line, take for example longer pulses, slower sweeps, but in an offline quality control board you do sample testing to get to the full Pmax. So that combination of inline quality control where you don't reach the full Pmax, but offline you do sampling and you stabilize all the thin film modules, for example. In the thin film industry that is quite standard practice, and I can imagine that for perovskite it might work as well, that you apply a certain offset to the stabilized power output in a quality control board. Yeah.
Okay, and then Veronica, you have all this in the field, and then you have to make some troubleshooting, and I can promise you some more these PIG whatever defects will come. So
that,
what do you think?
I think that is still very, very ahead in the future. No, we are not yet there. And listening to all of you, I completely agree with Hanson. I mean, it is just let's go to the basic of the materials. And I'm saying that because I spent more than 15 years in CIGS, and I'm seeing the same discussions. And one of the main problems of CIGS is there was only one word, CIGS, but so many materials within CIGS, depending on the composition, the stoichiometry, the fabrication method, many things, the layers, the buffer. When we wanted to substitute camion-based buffer by zinc, we saw a lot of metastabilities, and we started to say, stabilize 5 minutes. Others no, 10, because my material are not stabilized at 5, 15, and all this instability is going up and down. So first, my opinion is, what does it mean perovskite? Which is the material we are testing and which is the material we are characterizing, and compare just apple to apples, even if it is called perovskite. And only like this we will be able to make progress. Otherwise, you guys will be still suffering, and I will not see that in the field.
That's good. Good. So then, one more question rounds to the audience. Any questions?